Good evening. Now in this we are again going to solve problem that is May 2018 university question papers. So if you will solve so many problems, then you need not require to worry about your marks. So now we have this as VA. Now try to understand this. Sometimes may ask on this. So I have kept this one problem of UVL. So we have to convert it into two parts. One part we have that is of UDL. UDL height we have 8 kilonewton per meter. And UVL height also we will have total 16. So 8 UDL because this is 8 given and that is uniformly. And this is again 8 kilonewton per meter. So now for this UDL, it will act at center and we have this value that is 8 into 5 and that is at 2.5 meter, 5 by 2 from both sides. So 2.5 and 2.5 meters. Now if we will go to UVL, now we know we have UVL that will be total load is 1/2 base into height. So we have this as 1/2 base we have 5 and height we have 8 because we have taken this will be my triangle. So we have 4 pies are 20 kilonewtons. And then we have this distance will be from right angle, it will be L by 3. So we have this will be 5 by 3. And from other side, we have this distance as 10 by 3 from A. And then we have to find the reaction. So now we will take moment about, you can take anywhere, moment about B0 if we will say, then we have VA into 5 minus, so this is 8 into 5, 40 and act at 2.5. So 40 into 2.5 and then minus 20 into 5 by 3 and that is equal to 0. So if UDL comes, then we need not require to worry about it. We should be in position to solve it very clearly. And then we will get from this that reaction that is equal to 26.67 kilonewton. So we have VA 26.67 kilonewton. Then we can apply Fy0 and then we have equal to VA minus 40 minus 20 plus VB equal to 0. And from this we will get therefore VB equal to 33.33 kilonewtons. So we have value of VB that is 33.33 kilonewtons. So likewise we have to find first reactions, but practice it. You have to solve SFD BMD, so you have to go very fast. So we have VA 26.67 kilonewton and we have VB 33.33 kilonewtons. And now we will start with shear force. So we have shear force. Now we have first left of A, we have 0. Then we have right of A. We have 26.67 kilonewton. So we have right of A 26.67 kilonewton. Then we have left of B. So we have left of B. So we have 26.67 minus due to UDL 8 into 5 which is 40 minus due to UVL half 8 into 5 20 and this will be minus 33.33 kilonewton. Now we have here x to the power 1 So we should have x to the power 2. As my load, UVL load is increasing, you can see. So my slope of the curve should increase. So we have this will be increasing slope, and value we have 33.33 kilonewton. And then we have last, right of B, we have 0. Right of B, that is 0. And then we have this will be 0. And this is x to the power 2. You can see our slope is increasing. That is most important as my load is increasing. So you can see my slope that is go on increasing. And here I have this slope as maximum. So we have this will be maximum. So likewise, we have to plot it. Now we have again shear force equal to 0. So we will consider a part where we have this as x. So we have this will be 8 kilonewton per meter. So this is 8 kilonewton per meter. And then we have this will be UVL. Now try to understand, this is most important point. So we have this as y. So we have this as x. Now we have to use similar triangles. So in one triangle we have this value, we have 8 and this 5. And then in another triangle we have this value, that is y and x. So we have to write y in terms of x. So how we will write it? So we will have this as y by x, and that is equal to 8 by 5. And then we will get it as, therefore I will say y equal to 1.6x. So we have value of y is 1.6x. And now we have now simple, we have this reaction as 26.67. So summation Fy, we have to apply 0. So we have 26.67 minus, we have 8x minus, we have that value 1/2 into 1/2 base, we have x, and now height is 1.6x. So 1/2 xy, and we have that value of y, that is 1.6 and 1.6x. And from this we will get, that is 2 8s are, so 0.8x square plus 8x minus 26.67 equal to 0. And from this we will get value of x, that is equal to, I will just calculate in 1 minute. So we have 0.88 minus 26.67, and it comes 2.64 meters. So we have this value 2.64 meters. So this distance is 2.64 meters. 2.64 meters. And this is point of maximum bending moment. So now we will go with BM, we will go for BMD. So we have this as 26.67 and this we have 33.33. Now BMD we have simple. We have find out bending moment. Bending moment. We have to find at A now. First at A, it is 0. And then we have to find at C. And this distance we have 2.64 meters. And now you have to be very clear at shear force 0, M max. And then we have to actually plot this. So we have this distance 2.64. This we have 26.67. Then we have UDL first 8 kilonewton per meter. This is 8 kilonewton per meter. And then we have UVL. Now keep in mind, we have seen what is UVL value. So we have this value, that is 1.6x, and this becomes 1.6 into 2.64, and this comes 1.6 6 into 2.64, 4.22 4.22 kilonewton per meter. And now we will take maximum bending moment. We have 26.67 into 2.64 due to reaction minus due to UDL 8 into 2.64 into 2.64 by 2, and due to UVL is 1 half. Base we have 2.64, height we have 4.22, and at it is from right angle. So we have 2.64 by 3, x by 3. And we will get this value, just I will calculate 26.67 into 2.64 minus 4 into 2.64 square minus we have 0.5 into 2.64 square into 4.22 divided by 3. And this value is 37.6. 37.6 I got. So 37.62 kilonewton meter. Now here you can see this value is 37.11. So here I have round up these values. So I have taken this 4.22, and likewise, actually this is 4.224. If we will take this value, then this value comes 37.11 kilonewton meter. And likewise, we can find for UVL also. Now we have this next, that is draw the loading diagram and bending moment diagram for this. Now we will start with, first we have loading diagram. We have loading diagram. And in this we have, that is first at A, now we know we have final shear force minus initial shear force. Now we have final shear force, we have 7 minus initial we have 0. So we have 7 kilonewton. So you can see this. We have this as 7 kilonewton upward. Then we do not have any load between A to D. Then we have between D to E. D to E, we have W. Now we have final shear force minus 2, initial minus 2. And span we have 4 meter. So it comes minus 1 kilonewton per meter. So we have UDL. Sorry, before this we have actually this as 7 kilonewton. So I will write here second at D. At D, we have final shear force minus initial. Final we have plus 2 and initial minus 7. So we have minus 5 kilonewton. So we have this as downward 5 kilonewton. This distance, it is going from 7 to 2. So finally it's plus 2. And then we have third between this minus 1 kilonewton per meter. Then we have at E. So we have at E, and we have again final minus initial. So we have final minus 7, initial minus of minus 2, and we have that is again minus 5 kilonewton. It will be again downward. And then we have that is at B. At B, we have final shear force at B at 0, and initial we have minus of minus 7. So we have 7 kilonewton. So you can see we have 7 kilonewton. So likewise, we can plot loading diagram. Now we will go bending moment diagram. So we have bending moment at A. So now bending moment. Bending moment. So we have first at A, we have 0. At A, we have 0. Then we have to find second at D. Simple, we have 7 into 3, 21 kilonewton meter, because distances are given. This is given 3 meters. This is given 4 meters. This is given 2 meters. Now it is symmetrical. So you can see with center symmetrical. So we have shear force 0 at center. At center. And therefore, we will get therefore bending moment max, and that is equal to, we have 7 into 5. So now we are taking portion. So this is 7. We have this as 5. And for 2 meter, we have this UDA. Means we have this as 2 meters. We have this as 3 meters. And total we have 5 meters. And then we will get it 7 into 5 minus, due to concentrated load, 5 into 2, and due to UDL 1 into 2 into 2 by 2. And from this we will get this value, that is equal to 35 minus 10 minus 2. And then this value will be 27. So now you can see we will plot these values. So we have 21, sorry, it comes 23. So 7 into 5 minus 5 into 2. Sorry, this is minus 1 into 2 into 2 by 2. So this value I got 27. So I will check it, 7 into 5 minus 5 into 2 at center, and minus UDL is 1, span is 2, act at center. So it comes 23. So yes, 35 minus 12. So we have this value as 23 kilonewton meter. So we have 23 at E, again 21 at B, 0. So we have 4 at B, that is 0. So likewise, we have to solve the problems which are related with your SFD BMD. So now we will stop here only. Remaining part we will see in the next video. Thank you.